This is Steve Benzer with a short video about radio broadcast tower site, lightning protection, and grounding. I'm here at a small facility in the Midwest United States, the location of which will remain a secret unless you can figure it out from its looks and the terrain. This is a typical prefabricated 10 by 15 foot communications shelter. This is a 700-foot guide communications tower, at the top of which is a typical multi-bay FM broadcast antenna. I'm going to take us outside to look at the building between the tower and the wall, and then inside and maybe back outside. I'll discuss what's right, what's wrong, what's missing, and missed opportunities. So let's go take a look at the building and the package air conditioners and the tower. 700-foot radio tower. I believe it was made by ERI in Indiana. Okay, so we see that the lines, the first thing I'll observe is that the transmission lines, we've got a 7/8 STL line and a 3-inch flexible heliax line for the transmitter entering the building. I noticed that there's a good ice bridge, which has trapeze sections to hold the lines, a shield above to prevent falling ice from damaging the lines. It's not too close to the ice bridge to get cut, and the trapeze hangers look good. There's an entry port with boots, rubber entry boots on the building, but I see something's missing. There's no grounding kits, and there's no lightning protection outside the building. There should be grounding kits on the transmission lines, a bus bar, and a copper strap down into the ground. I do see that there's a tin-plated number 6 copper wire coming out of the building, going into the ground. Presumably it's connected to the same system of ground rods, should there be any, that these others attach to. So there's 3 wires off the base of the tower and 1 out of the building. We're looking for anything that can take lightning to the earth. So let's go in the building and see what these things connect to. Here in the building we have a typical broadcast transmitter, on top of which is a copper low-pass filter, some metering sections, and the transmission line. There's a lot wrong here, but I'm focusing only on the lightning protection and grounding. I noticed that there's no grounding kits on any of these transmission lines, that they instead go straight to the transmitter without any benefit of grounding kits. There is a grounding block on the wall and a copper strap that comes down from the wall, connects to the power supply vault that makes its way across the floor to the equipment rack and the broadcast transmitter. Presumably, these are all tied together. Can't tell because there's a power supply there, but let's presume that this copper strap ties everything together. So lightning has an incredibly fast rise time. Let's say it's a microsecond. Lightning will come in on the transmission line and then have nowhere to go but to the transmitter. From the transmitter, it may find ground through this strap. So already we have lightning going through the case of the transmitter to get to the strap. But then the strap isn't earth grounded anywhere. Instead, the strap rises up 7 feet to a grounding block, which then makes a U-turn and connects to this copper line and goes down out the building to the earth. So this is a big horseshoe, and lightning will not take that path. Lightning will take the path of least resistance and least inductance, and this is a big inductor. And so lots done wrong here, lots of good material, but employed very poorly. There are some good things done here. There's a halo ground. This halo ground goes all the way around the building and returns to the same point and then is grounded, earth grounded. So that's about the only thing that's done right. The fix is very simple. I'll slice a hole in the bottom of the building, and I will connect this strap to an earth ground outside the building and tie both straps together. That will take lightning to the ground. And then on the outside, a grounding kit or two to a similar bus bar will take the lightning to the ground. So let's go outside and see where the grounding kits could be. The first line of defense is to keep lightning out of the building. So 2 grounding kits on these coaxial cables, their tails to a grounding bus bar on the side of the building, and then a strap, copper strap down into the ground, which will be attached to this wire, and that will provide lightning protection. But as far as what exists in this building, the grounding was not well thought out or executed. It was just installed in a way that kind of looks right. There's good DC grounding. Everything is a really good earth ground. But as far as lightning protection, lightning will not take the path of these lines. Instead, at this site, a direct lightning strike to the antenna may go through the transmission line into the transmitter and seek earth ground somehow through the transmitter case, which means blown up electronics, blown up rectifiers, controller boards fried, and being off the air. This is all preventable and pretty easily remedied. But just wanted to make a short video that showed that even though you see a bunch of copper and a bunch of wire, and there's some things in the ground, lightning will not take that path. You have to think like a lightning bolt. Imagine you have a microsecond rise time, and you're going to go to Earth the most direct route as far as geometry. Lightning will shoot off the edges of sharp objects and reach the ground instead of taking a loop or an inductive path. All right, there's the video. Bye.